Building on what we did in topic 3, well, topic 2, we're going on to topic 3, where we will be dealing with polynomial equations, and then we're going to be able to solve them through factoring. Now, if you have a graphing calculator, there are ways to graph solutions, but we will primarily be doing our solving of these quadratic equations using algebra. And to do this, as I mentioned before, we're going to need to do factoring. And this will be a skill we will particularly work on. Now, throughout many of these lessons, we're going to be using this principle of the zero factor, which, if you looked over your textbook, you would have seen something like this. AB equals 0. Now, here, this is some variable. This is a different variable. And if we are multiplying these variables, and the product of these two factors is equal to 0, then in order for this to be true, either A or B had to equal 0. Because if A is 0, 0 times B is 0. And if B is 0, 0 times A is 0. The principle of the zero factor. In order for this to be true, either the A or the B has to be a 0. Okay? Now, in order to do this, there is some maneuvers we have to do. So let's take example A here of number 1. And what I'm going to do is take this 10 that's on the right and move it to the left by transposition. And we're going to then equate it to 0. So we're starting to get it in this form here. Now, you might say, what do I do here? Well, I have to factor this. And is there a common factor in each one of these terms? And the answer is yes, there's an x there. I can factor out an x. I'm doing the reverse of the distributive principle, and I get x minus 10. And then I equate it to 0 still. Now I have two factors. I have x, in a sense, could be my a, and x minus 10 can be my b. So the rule then is to take each of these factors and equate it to 0. X equals 0, that's sort of like this, or, and I usually put that in there, x minus 10 equals 0. So here, this is already solved. We're saying that x could equal 0, or x minus 10 could equal 0. But I have to solve. What would x be here? Well, x here would be a 10. Now I go in there and I say, if x is 0, 0 times 0 is 0. And if this x here is a 0, this one, 10 times 0 is 0. So 0 is a possible answer. How about 10? Would 10 be an answer? Well, if x is 10, 10 squared is 100, and 10 times 10 is 100. So yes, 10 is a possible answer also. So that is the solution for letter A. Now, in example B, it gets rather complex because many of the skills they're going to ask us to use to do letter B, we're going to work on those down below where we have to factor this. But we will be using throughout this lesson the principle of the zero factor. So you should have all of this in your notes and maybe put a little star by that or 2 stars, because this is a very important principle that we will be using. And we'll be going through the stages of factoring here very shortly. Now I've raised it up a little, and letter B here, we're going to get back to that in a little while, because they give us some of the material here, the way they have this set up. I would put that one down at the end, but here they've put it. But let me mention one thing here. This is a phrase you're going to see and read every once in a while. It's called find the zeros of a function. Now, when they say that, all they're saying about some expression they're giving you, in a sense, this is y here. They're saying that this y is going to be a 0. So when they say find the zeros of a function, and I'm putting this y in a sense over there and changing the y to a 0, that's finding the zeros of a function. So this is the function, and we equate the function to 0. Okay? Now, again, we'll get back to the factoring of that in a little while. But let's look at this one right here. Solve this equation. Now notice what it does is it has this we can think of as A, this we can think of as B, so it's A times B equals 0. So we are using the principle of the zero product. So what did we say was the rule for solving this? This is already in its factored form. So we said take each of the factors, x plus 5, equal it to 0, and physically write the word or, x minus 1 equals 0. This is the strategy, the protocol for solving when it's factored and it equals 0. This is probably the easiest kind you're going to have. Now all we do is just transpose that, and we get x equals negative 5, and here x equals 1. So if it's a negative 5 here, negative 5 plus 5 makes this 0. 0 times anything is 0. And if this is a 1, 1 minus 1 is 0. And if this is 0 times anything, it is 0. We are finding the zeros here. Now, here's another case where it's in function form. There's our expression, but it's factored. So we're just going to take this, equal it to 0, because this says y equals 0, and we write it 2x equals 0. That's, in a sense, this is the A, and what's in the parentheses is the B, and we're equaling it to 0. And then we say, or 4x plus 1 equals 0. So here we divide both sides by 2, and we get x equals 0. Here we're going to transpose the 1, get a negative 1 on that side, 4x, divide both sides by 4, we get x equals a negative 1/4. We have found the zeros. This is in factored form, and we use the principle of the zero product. A, B equals 0. This is one factor, this is the other factor. We take each factor and equate it to 0. A equals 0 or B equals 0. All right, let's go on. Now, if I were going to set up this mini lesson personally, I would have done this earlier and then what we did already later. But I didn't do that. This is what we have. So they want us here to factor now this. And basically what it is, we want to see if we have a common factor in both of these terms. Well, is 4 a common factor? No. If this were 16, it would have been. So the only number factor that I can see here is we have a 2 that is common to both of these numbers. And there is no common variable. So we're going to take a 2 out of the 4 and we get a 2 left. And a 2 out of the 18 and we get a 9. And that's the most, because now what is in the parentheses, we can't take any more common terms out. So this was the opposite of what we did earlier when we distributed the 2 through this. Now we're reversing it and factoring, taking out the greatest common factor. Now for letter B, we're going to do something similar. We want to see what common factor in terms of the number that we can take out of each one. Well, I can't take a 6. I could take a 2 there, but not there. So it looks like what? What can I take out of each one? A 3. Okay? And in terms of the letter, here I have A to the 4th, A to the 3rd, A to the 2nd. So it's actually the one you can take out of each one. And that's sort of the smallest. That would be A to the 2nd. So I can take out A to the 2nd here. Then I look at B. B to the 2nd, B to the 3rd, B to the 5th. I can take out B to the 2nd. So that's what I'm taking out of each one of these. Now when I do that, what's left? Well, here I get 3 and there goes 2. Let's just do the numbers first. This is going to be a negative. This number is going to be 3. And this is going to be a negative, and that's going to be a 5. So we're just kind of showing you how we're teasing this apart. Now we can take a to the second out. What's left? Well, a to the second. And we took out b to the second already, so nothing else there. Now here we take out a to the second, so we're going to left with an a. We're taking out b to the second, so we're left with a b. And you may need to look at this very carefully. And then here the a to the second goes out. We have b to the second, b to the fifth, so we're left with b to the third. Now you might say, I'm finished. I'm going to leave it like that. Well, no. What you should do is now look at what you have here. Can you take out anything from each of these terms? Because if you miss something originally, you still have this chance. And you say, no, there's nothing else there. Are my signs correct? If I distribute this, do I get this product again? Again, you want to develop accuracy. You want to get the most points you can on any test down the line that you take. You want to do your practice. You want to write it out neatly. You want to develop skill in mastering this type of example. Okay, now let's take a look at this one. We're working on a way to do it. So I have three terms. I'm going to have three spots in here. I want to see what can I take out of each one of these. Now I can take out a 2 from each one. No, I can take out a 3 from each one. All right. And if I could take out a 2 and a 3 from each one, chances are I could take a 6 out of each one. Let's see what we get here. I'm going to try it. I'm going to take a 6 out of each one. We'll just do the numbers. So 6 times what is 18? 3. 6 times what is 24? 4. 6 times what is 48? 8. And that's a negative. 6 times 8, 48. And my signs are good. Now I look at the letter. And I see I have x to the fourth, x to the third, x to the second. Well, what power of x can I take out of each one? And it would be the smallest, x to the second. So here I'm left with x to the second. Here I'm left with an x. And here I don't have any. And I look in the items that I have in the parenthesis. Can I take anything else out? No. And no letters out of each one. So that is the answer. What's this process called? Factoring. It's the opposite of the distribution principle that we worked on earlier. Okay. Now as we look at D, they're asking us to factor out the common factor, but we want it to be a negative coefficient. So I'm going to take away this because it's going to be in where I need to work. So again, we're looking for strategy here. We're going to need a parenthesis for 2. 1, 2, 3, 4, parenthesis for 4. 1, 2, 3, a parenthesis for 3. Just setting this up. Now we want each of our things that we're going to take out to be negative. So here, in terms of our number, what can we take out? A negative 5. So what will this be here? A y. Now notice when you multiply these, you get this. Now here, this is a negative. In order for this to be a negative, what do I take out? Well, it has to be the opposite sign than what I have, because I took out the negative. That's going to reverse the signs, and this is going to be a positive 6. So when I distribute, it checks, and I have what they have directed me to do, take out a negative common factor, negative coefficient. Okay, so here, what can I take out of each one? I have a 4, a 2, a 10, and a 2. Think about it. A negative 2. So, what does this do when I take out a negative, by the way? It's going to change all these signs. This is going to be a positive. This one's going to be a negative. This is going to be a positive. And this one's going to be a negative. Positive, I should say. I got carried away there. Opposite signs. By taking out a negative, you're changing all these internal signs. And I'm trying to do this in little pieces so you see what's going on. Now, so what's left here? And what letter can I take out, by the way? X to the fourth, X to the third, X to the second, X. I can take out an X out of each term. So this is going to be a positive 2x to the what? Third. This is going to be a negative because I already determined it has to be opposite signs. X to the second. This is going to be 5x. And then this is just going to be a positive 1. Now, you might say, do I need that 1 there? And the answer is yes, because when you distribute, you want to be able to get this product. And if you don't have a 1 there, then you lose this term. And that's an error students make sometimes, so be sure to watch that. Always check your work. And as you look in here, there's no more common terms. And notice what happens. This became a plus, this became a plus, this became a plus. This became a negative. And why? Because we took out a negative coefficient. That changed all of the signs within the parenthesis. So in letter F, we have a negative 3, a 9, a 12. So what number can we take out? We want it to be negative. And the answer is 3. Now we have a x to the second, x. So we can take out an x. We have y. We can take out a y. Now, this one is going to be a positive. This is going to be a negative. And this will be a negative. So let's work on our signs here, or when we factor out. So here, what are we going to have left? Just the x. Here, we're going to have a 3y. And here, we're going to have a 4. And that's it. And you can't see that negative very well, so let's make it nice and big there. And take out a little bit. There we go. Okay, now again, the answers are all down below. And we want to look at the skills we're building, because now we're going on to another skill. And I should mention that the a lot of our factoring examples I do in another video called Additional Exercises, where there's lots of exercises that I go through item by item and factor them for you. Here, this is just to give you some particular pointers on it, but of course you're going to need to practice as you do your study plan and your quiz-mes to earn your mastery points. So you know what's going to happen when you take the test. Okay, we're now going into another kind of factoring in number 4. This is called factoring by grouping. And this is going to lead us to one of the ones up on the top there. So here we see we have 4 terms. Is there anything common? In fact, I'm going to write these out here. In any of these? And the answer is no. But we see 4 terms. We then go to possibly consider factoring by grouping, where we look at the first 2 terms. Is there a common factor in these first 2 terms? And the answer is yes, there's an a squared. So then we get an a minus 5. Now as we look at the last 2 terms, is there a common factor? Yes, there's a 4. And lo and behold, I get a minus 5. Now as we look at these, is there a common factor? And this is now 1 term and this is 1 term. Is there a common factor? Well, yes, this is a common factor. A minus 5. So what we do is we put our a minus 5 here and then take our 4 and our a squared and put that in another parenthesis. And we have factored this using the concept of grouping. Now you may recall in an earlier lesson we said that sometime when you are multiplying a binomial by a binomial, you take your first binomial member and multiply it by the second. That's what we've done here. We take our second binomial member and multiply it by the second binomial, which is what we've done here. Then we just distribute and we get that. So using an earlier technique, not the FOIL, but the more traditional way of multiplying a binomial by a binomial, we are just reversing that. All right, let's do B. Now as we look at B, and I gave it a quick look, it didn't seem that by grouping that was going to work. But if I rearrange them, put them in descending order, watch what happens. Out of these first 2 now, I can take out a 3x, and I get an x squared well, I get an x squared I can take out actually. So I get an x there. That's what I want. Plus 2. Now, what can I take out of this? I can take out a plus 10 and get x plus 2. So now I have 2 terms. My common factor is this, that I'll put here, x plus 2. And I'm going to bring this term and this term in here. Now keep in mind, this is your model of how to do things by factoring, by grouping. And let's check it out here. Number 4, 4a is what we have, and 4b is what we have also. Okay, let's do 4c. Well, I had to do some organizing of this. And again, I have a 6 and a 3, a 4 and a 2. So that'll give me something to work with. But let's work on this one first. So I can take out here a 3, B. BY, I guess I can take out. And if I copy them down correctly here, I had that incorrectly copied. So I can take out a 3b out of each of these terms, and I'm left with a 2y minus x. That's better. Now here's a case where the signs seem to be wrong. But if I take out a negative out of each one of these, it's going to reverse the signs. A negative 2a out of these two, watch what happens. I get a 2y minus x. That's what I was looking for. So that technique that we worked on up there is going to be very useful here. So again, our common factors in each of these two terms is 2y minus x. That's this. And then we put the other 2 right here. And that should be correct if I can find where we are here. So we are 4C. Okay, it works out the same. I see we have things switched around a little bit, but this is satisfactory. Yes, that's okay. Going on to number 5, and I see the tape is running long. Didn't we do this one already? Maybe. Let's see. This is in what we call standard form. We're going to factor this now. We want to find the zeros. So we're going to factor out a 5x, and we get x minus 2 equals 0. Equate each of these, 5x equals 0, or x minus 2 equals 0. Divide both sides by 5 here, x equals 0, and here x equals 2. So there they are, 0 and 2. And I didn't explain it super, but we did cover this earlier. We have one to go back to, which is letter B up here. And that will be sort of interesting. After looking at this particular function, you can't solve it by grouping. And the only way we could solve it is by graphing it using a graphing calculator. Now it looks a little bit like this, and when they're asking you to find the zeros, they're actually asking you to see where does the graph cross the x-axis. Well, it crosses the x-axis there. So remember, what is your y value when a line crosses the x-axis? Well, it's 0. So when they ask you to find the zeros, It's where in the graph the line crosses the graph. So it crosses it here at -5, -2, and a 3. But again, we're not able to solve that doing the techniques we have shown you below. So you will not have any like this on your test unless they give you the graph and you just pick out your zeros for y. X is this, X is that, X is this, when Y is a 0. That's what they're asking you here. Okay, 35 minutes. We're getting into some heavy things.